Wonderful people, you're welcome to Make Boss channel. This is my handle Make Boss tutorial. Hashtag you don't need to be a scholar to get an A. Okay, let's continue with our set theory. Now this is the part 2 of set theory. Now in the part 1 we talked about, I introduced to us the definition of sets and the notations involved in set, and we saw many examples on that sets. Today we are going to be going into something called the Venn diagram. Can we all say Venn diagram? The Venn diagram. Now the Venn diagram consists of let's look at the definition of the Venn diagram. But this is generally how the Venn diagram looks like. This is a two Venn diagram. This is consisting of two oval shapes. This is a three Venn diagram. This is a Venn diagram consisting of three oval shapes. Is that okay? Now, what is a Venn diagram? A Venn diagram is a diagrammatic or pictorial representation of sets. Ovals, like the one shown below, were first used by John Venn. So John Venn is practically the inventor of Venn diagram. So let's stop with this English and solve some questions. Now look at this first question. This first question is just to teach us the representation of normal set notations using Venn diagram. But if you have the basic understanding of 2 by 2 of two ovals in the Venn diagram, you can skip this part 2 and go to part 3, in which we talk about the three ovals. Is that okay? But in this part 2, we are going to be focusing mainly on the two oval Venn diagram. Is that okay? Now let's continue with this example. Our universal is defined as is a natural number from 1 to 10. So our universal contains numbers 1 to 10, and subsets from our universal are A, which is even numbers from 1 to 10, and we got the element to be 2, 4, 6, 8, 10. And B, multiples of 3 from 1 to 10 is 3, 6, 9. To represent this in our Venn diagram, the first thing you do is you draw a box. This box that you see here is called our universal. Is that okay? It is called our universal. Then you draw your subset. Your subsets are the ovals. This first oval here is our subset A, while the second oval is our subset B. Now, if you look at element of A and we look at element of B, we can see there is a slight resemblance. Yes, we can see there is a slight resemblance. The resemblance is 6. You see, 6 is present in A and also present in B. So 6 is common, right? So since 6 is common, our oval must intersect. Even though they're supposed to be in something like this separately. Assuming A and B do not intersect, they'll be separate, right? This is not an oval. Well, we are just assuming. So they won't intersect, assuming we had nothing common. But because we have something common, which is 6, they intersected. So in this place, this is called our intersect, right? And this is what the elements common between our first set and our second set. Is that okay? So these 2, 4, 6, 8, 10 are the set of A. We don't repeat 6 again because 6 is already here. And these B's are set 3 and 9. That's 3 and 9. Is that okay? So if someone asks now, what are the elements of B? Without looking at this, you can say the elements of B are 3, 6, 9. The elements of A are 2, 4, 6, 8, 10. Now, this 1 and 7, why are they there? 1 and 7 are the complements of A and B, the complement of the union of A and B. What do I mean by that? It means they are in the universal but not in the subset A and B. I'm sure we all understand this example. Let's quickly go on to our next example. Okay, our next example says, in a class of 35 students, 25 speak French, 15 speak German. How many students speak both French and German? When they say both French and German, we are talking about French intersection German. Okay, that was a mistake. Let's clean that. We're talking about French intersection German. Is that okay? So in this case, I said let X be the number of students who speak both French and German. It means F intersection German, that's French intersection German, is equals to our X. Is that okay? So drawing our Venn diagram, we have our universal to be the box and our ovals to be the subset. So the first oval here is for French. The second over here is for our German. Now, in our French, we have how many? We have in the universal, our universal is equal to 35. Do you see there? Universal is equal to 35. For French, we have 25 who speak French. That's why we have 25 here. Now, for German, we have 15 who speak German. Then we have X, which is common between French and German. So we have X number of people that speak both French and German. Now to solve this, you say 25 minus X, and you also say 15 minus X. Now, how do you find X? You just add up everything here. Is that okay? You add up everything, and that's what we did here. Now, to find the value for our X, what do? We just add this plus this plus this, everything here. So we have 25 minus X plus 15 minus X. We can see that minus X will cancel plus X, they cancel each other, right? Then we have 25 plus 15 minus X. 25 plus 15 is 40. If we take minus X to crossing over 35, what do we have? We have plus X. So if we take 35, if 35 crosses over, what do we have? We have minus 35. So X is equal to 40 minus 35, which is equal to 5. So our French intersection German, which is equal to our X, is equal to what? To 5, right? So 5 number of people speak both French and German. So how many people speak French? You can say 25 minus our X is what? Is 5, right? So 25 minus 5, which is equal to what? 20. So 20 people speak French, and 15 minus 5 is what? Is 10. So 10 persons speak German. So I think we are through with this question. Let's go on to the next question. The next question says, in a class of 40 students, a student can study French or history or both. If 20 that means our universal is 40 students, which we have here, 40 students. If 20 students study French, that means French, we have what? We have 20 students. 23 study history, 23 studies history, and 6 study neither. That means 6 is the complement of the union of both French and history. What do I mean by that? I mean French union history, then complements. That's what we mean by neither. Is that okay? Neither. How many students study both subjects, meaning intersection, right? So we are looking for how many students study French intersection history, right? So let's assume French intersection history equals A. So that's why we have A here. Okay, so we have A here. So what do? We say 20 minus A. We say 23 minus A. Is that okay? Let's make our work neat. This 6, we do not subtract A from it, only those things in the ovals, right? So this A is subtracted from 20, A is subtracted from 23. To find our A, what do? We add up. Okay, to find our A, what do? We add up 20 minus A. So let's add it up. Now we have 20 minus A plus A plus 23 minus A plus 6 equals to our total is what? Is 40, right? Good. Now minus A cancels minus A. So 20 plus 23 is what? Is 43. 43 plus 6 is 49, right? 9 minus A equals to what? Equals to 40, right? Equals to 40. So 49 minus A. So if we collect like terms, we can see that all of this will give us 49 minus 40. Because you should understand how I got that. So A will be equals to 9. So the value of A is equals to 9. So how many people study both subjects? That means people who study French intersection history is equals to what? Is equals to A, and A is equals to what? Is 9, right? So I think we've answered that question. Okay. So I think this is the real solving here. So this is the actual solving. Let's continue to our next question. Our next question says, in a class of 500 first-year students in a school, 350 study chemistry. That's why we have chemistry 350 students. Let's clean that. 350 students. And 200 study physics. So that's why we have 200 here. 90 study neither. That's why 90 is outside of the two ovals. Now, the first question says, how many students study both subjects? Both subjects. Let's say the subjects are chemistry and physics. So we can say chemistry intersection physics, or let chemistry intersection physics equals A, or rather equals X. Let's clean this. So the two ovals are intersecting with X, right? So the people who study both chemistry and physics are in this particular place, which is represented by X. So what do? We subtract X from chemistry, we subtract X from physics. That's why we have 350 minus X and 200 minus X. To find X, as we've said, you add up everything. So we add this plus this plus this plus this. Is that okay? Now, doing that, you see we have 350 minus X plus 200 minus X plus 90, which is equal to what? To 500. Now, 350 plus 200 will give us 640 minus X cancels minus X. What remains here? Minus X. Collecting like terms, our X is equal to 640 minus 500. So X is equal to what? To 140. So the number of students who study both subjects is equal to what? Is equal to 140. So in this case, the cardinality of chemistry intersection physics is equal to what? 140 students. I hope you got that. Let's go on to the B part. The B part says, how many students study only one subject? Meaning, how many students study only chemistry or only physics? Now, to do that, we say N. This N, remember, is cardinality. So C intersection P complement means the student here study only chemistry, not physics. And C complement intersection P means the student here study only physics, not chemistry. Is that okay? Yes. So I think, so now, number of students that study only chemistry, not physics, is what? 350 minus X. That's 350 minus X. Okay. Now, number of students that study only physics, not chemistry, is 200 minus X. So that's why we have 350 minus X plus 200 minus X. 350 plus 200 will give us 550. Minus X will give us minus 2X. We know our X will be equal to 140, right? So in our, we'll put 140 in bracket. 2 times 140 is what? 280. 550 minus 280 will give us 270. So those are the numbers of students who study either chemistry or physics, that study only one subject. I'm sure we got this example. Let's move on to the, I think, our last example under this part. Now it says, how many students study at least one subject? How many students study at least? When we talk about at least, it means how many students study one subject or more. But it must be one subject or more. So they cannot study, we are not looking for students that study less than one, but either one or more. So and to do that, we have to first write students that study only one subject, which is N, which is C intersection P complement and C complement intersection B. These are the numbers of students that study only chemistry. These are the number of students that study only physics. While these are the numbers of students that study both chemistry and, and physics. Now, So from our Venn diagram, we have this to be 350 minus x, then plus x. This is not a, this is x. Okay, plus x plus 200 minus x. Adding these, we have 350 minus x plus 200 minus x. So minus x cancels minus x cancels plus x. 350 plus 200 is 550. Then we have minus x remaining. So we know x to be equal to 140. So 550 minus 140 is equal to 410. So the number of students that study at least one subject, that is one subject or more, is equal to what? To 410. So I'm sure we all understood this video. Thank you for watching. Make sure you like and you comment and you subscribe to our channel for more videos, or for the part 3, which will be coming soon. Thank you very much. See you in our next class.